So you've got a point and a slope. So in this case here, I would just start writing it out. As you write it out, excuse me. It only takes a second to write the formula down, so that way you know for certain that you're not being a doofus and writing the wrong things in. Substitute in x minus 6, 1/2, x minus 4. Combine your like terms, we have 1/2 x minus 2, add the 6, we get plus 4. Oh, sorry, that should be a y here. Sorry about that. I think you should get plus 4 when you're almost set down. And that would be an equation of a line that's parallel to the 2 points that contains the element. No, you don't need to graph it. No. A lot of times it's writing the equations. Speaking of graphing, we also did a lot of graphing. With graphing stuff, we were able to work through some of our shortcut things, and we learned that this one, it's 2/6. We're doing stuff like this. When you're doing your quick graph, shaded inequalities, what we're doing in essence is we're covering and solving. Because when you cover and solve, you're able to figure out your x and your y intercepts. Now, when you have an x-intercept, what's your what's the value for y? 0. When you have a y-intercept, what's your value for x? 0. Does that always happen? Yes, that will always, always, always happen. So we know that in just rough sketching something like this, if I just want to cover and solve, that was the trick here. Understanding that when your x-intercept is when y is 0, then you just cover up the y value, solve for x. Do I cover up any of the signs that are preceding anything? No, I don't cover up the signs when I'm solving, because that way I know to use those values. So if I want to figure out my y-intercept, what do I get? When I cover up my x-intercept, what do I get? 3, yeah. Now, what was the trick for standard form for finding slope? The what? You don't have to apologize. Not like you farted or anything. Yes, sir. A over C and B over C, not quite. Very good. Opposite of A over B. So if you think about in terms of your slopes, when you're working with what we call standard form. Standard form was your AX plus BY equals C. If I wanted to get y by itself, what we would do first is move the AX. So that's where you get the opposite of A. And then we divide it by B. I never really worried so much about the y-intercept in terms of standard form, because it didn't matter, because I would just cover and solve. It was quicker. But this quick allowed us to get to our slopes. So remember, your slopes for standard form, I was called for a second there. Standard form would always be opposite of A over B. But if you forget that, does it take all that long to subtract 2x and divide by -3? It really doesn't. Okay, so it's one of those things that it's really, really good to remember this, because this will come into play a lot in about another week or so. I don't know if it will happen next week per se, but it'll definitely be the week after. Right, when we get into some more graphic stuff. So from here, we'd have to connect the dots, but we have to make a decision. Is it going to be a solid dot connecting those, or a dotted line? Why is it dotted? Correct. It's just less than, not less than or equal to. Okay. Then we have to figure out that this graph cut the plane into what are called 2 half planes. One half of the plane would be true, one half of the plane would be false. So the easiest thing to do is ask, did this go through the origin? Did it go through the ordered pair of 0, 0? No. So we use that as our test point. So what's 2 times 0? 0. What's 3 times 0? What's 0 minus 0? Is 0 less than 6? Yes. So that means it's true here, which means it is false here. And we're shady, folk.
Cover up the truth. You can't handle the truth.
Did you order the call red? Perfect time. I said you can't handle the truth, and then I asked you to read the code red. You're supposed to make your code. Yeah, right, I did. It would have been perfect if you would have answered it right away instead of being frightened.
Listen, I think you kill
What's wrong? I don't care. Oh, but I need to give this to What's that? Are you saying he's not good enough?
I'm not good enough, that's the thing.
He doesn't explain everything.
Whoa.
See, we're going to boost your confidence here. How about this? Let's raise your expectations. So stand up on your chair. Everybody, let's cheer for Ivan here. Come on, stand up on your chair. Stand up on your chair.
If I stand up on the chair, I'm gonna jump off.
You're not. Well, it's not that far, so you can stand up. You can do it.
Do I have to?
Do it. Say, you can do this. Come on. Anyway, all right. I don't know. What's the weird? I don't think there's any weird ones in this one. Once we got through all these things, these were pretty straightforward, right? Shading. Big idea here was just making sure you just cover and solve and go from there. After we did these things, we went into the piecewise functions. And remember, piecewise functions, for lack of better terms, are pieces of functions. And I thought, did they make a... Put them together here. No, those are absolute value. Oh, I had one Oh, I guess I don't have these ones on that one. Whatever. Piecewise was 2.7. And as we went through these things again, so back to the piecewise stuff. Another quick reminder of what we went through. As you do the piecewise, I'm just kind of cutting it off so you can kind of see it. Remember, piecewise functions are pieces of functions. They are domain restricted. What domain restriction means is that they're only going to be in there for a specific input. Only certain values of x will generate certain values of y. Right? Now, what we did here, there was a couple of methods of doing it. One of the methods that we did that was we kind of, for wherever break there was, we kind of drew in a little imaginary line to know that there was something weird going on. So there's something weird at 0, and there's something weird going on at 2. Then obviously there's something weird going in between the two. All right. So from here, what we did is we went through each individual piece, and we started to graph it. So the first graph says x plus 1. Well, what's your slope? What's your y-intercept? Slope is 1. Y-intercept is 1. So we would start there at 1, but immediately I'm on one of those imaginary little lines. So I have to look at the domain restriction. This domain restriction says that this graph is only going to occur for all values of x that are smaller than 0. So since I'm on that imaginary vertical line right now, what should I put to? An open or a closed document? Open. And the reason it has to be open is it's not equal to. Good. So I know that this boundary, I should not go up and right, I should go down and left. Okay? And I'm not hitting any other boundary, so I can just continue this one through. All right. I go to my second graph. My second graph says a negative x plus 1 between 0, including 2. Well, my y-intercept here is 1, and it overlaps with what we already had. So remember the trick that I said to do? If one of them's solid and the other one's open, we just make that open dot a little bit larger. So in this case, if that looks like that, you can get away with something like that. I think I told you guys that I will make sure that things get split a little bit, so you won't be as have to worry about that so much. And then we know that it goes, the slope is negative, so it goes down 1, right 1, and then I include it at 2 again. So there's those. And then lastly, the slope is 1 with the y-intercept of -1 when it is greater than 2. So we know we would start here, and then I have an open dot. I thought I started at -1. Yeah. I just didn't make a real dot there because I was just going to count because I was going to go that way. And then I would just connect them through. Piecewise, pieces of functions, domain restrictions. Ouch. I think you had your hand going. What's up? Yeah, I started there and I just kind of went dot, dot. I just started doing it to count. That way I knew not to make any pictures on that because I knew right away it was going to be something like this. Okay. The other type of function with these guys, the other type of function of this style was when we had what were called step functions. And when you had step functions, they just like literally looked like steps. All right. So let's see here. It's very convenient. So absolute value graph. When you do absolute value graph, remember the easiest thing that I would always do first is I always label my A, my H, and my K. Yes, sir. Yes, sir. That's the trick. H is always the opposite. K is the same. Now, in this case here, your A value is what? Negative 1/3. So if my A value is negative 1/3, what direction is my V going? The V is opening downward. So as soon as I write down my A value, and I know it's negative, I'm going to do that, so that way I know when I start graphing something, if I goof, I'll be like, oh, duh, and I can fix it, all right? My H and my K are what and what? That's 4.
Yeah. What?
It's bad. Sorry. So where's your vertex lies at? 2, 2. So we start at 2, 2. From that point, we just walk our slope. What I would always do first, since there's going to be one slope that's positive and one slope that's negative in this style, I always walk whatever the sign is first, because that tells me, all right, I know how to walk a negative slope. I have to go down and right, down and right. And then the other one, I just reverse it. Down 1, right 3. Down 1, right 3. Down 1, right 3. Oops. Sorry.
Perfect. So is the reason that it's a V is that because it's an absolute value?
The reason that it's V is because it's linear.
Like,
And the reason that
why
it's
do we like switch this from V to the
because it is the absolute value. Because as you, I thought you mean like this, why it's like this, not a curve.
Oh.
Yeah, it's linear because it's a singular degree, but it isn't V like that because of the absolute value. Same idea when you have quadratics. You're either up like a cup or down like a funnel because there's a curve to it. Even though if you have a negative value, when you square it, it becomes positive. It flips because your multiplier in the front changes. That's the same basic idea. Okay? And that's just because it's an even function. Yeah. Hey, go figure updates, right? Hey, look, let's do these now. No. It's super convenient. Super convenient how that always shows up. Right when you don't want it to. What else do you want to look at? Another side? Yes, sir.
What's a sticker on the wall?
A kid put a dinosaur sticker on here once, and it was a Tyrannosaurus Rex.
I was trying to figure out what it was.
Yeah, it's a T-Rex. One of my students a couple years ago, she's like, oh, I got a T-Rex sticker. I'm going to put it in your coffee mug. I'm like, okay. She's like, your kids will like it. I'm like, all right, whatever.
I don't have a sticker.
Now, you had one? Good, they want to help you.
Wait, what? Oh, yeah, I said dealer's choice or whatever you want.
Oh.
I can see that.
Dealer's choice. Yeah, so the other one from last night, what is that, 2-7? So last night's homework, there was number 25s being asked about. In this case here, at least we'll start it. So with this one, you've got negative 1/2 times the absolute value of x plus 6, and that's it. So that tells me that my A value is negative 1/2, which means it's a V going down. My H value
Yeah. Caitlin.
What's your H value? -6, good. What's your K value? 0, good. So your K value, shh, guys, come on. Your K value is 0 because it's not there. Can you say that it's 1? No, if it was a 1, you'd have a +1 at the end of it. The only time you can say something is a 1 by not knowing that it's there is an A value, a coefficient. We can't just add random 1s in places. So you know you would start this one at -6 and 0. Then a slope of -1/2. So on. So on. Oops. Yeah, close enough. Here we go from there. Oh, okay. Did you get it okay though?
Yeah, I was done with that one.
Yeah. That's good.
Can you go over something on the?
Which one?
I don't know.
We've done all of those. That's why I did the extra slope one. I did the slope one the other day in class. The one where you had the missing value. Did you have it on you?
Who are you?
Oh,
Yeah.
Wow. Advanced skills. The inequality one?
Yeah.
Well, that was just like this. So if I'm doing a linear inequality, again, it's a cover and solve. So my y-intercept would be at -2. My x-intercept would be at 8/12. 8/12 is what? 2/3. Okay? The x-intercept at 2/3, about there-ish. When I connect those two, would it be solid or dotted? Dotted. Why is it dotted again? Yep. Did this graph go through the origin? No. What's 12 times 0? What's 4 times 0? What's 0 minus 0? Is 0 bigger than 8? No, so it's false here, which means it's true here. Yep, and then the last part of this one was slope. The slope, for a second, sorry. The slope then here would have been the opposite of A over B, which is 3. Yes, sir.
where do you see?
Great question. If your problem ever goes through the origin, if it happened to go through the origin like this was at this spot here, what I would do is I would just pick any point that's not on the graph. I would pick this, and I would test it. All right, it's just you would, instead of picking 0, 0 being really easy math, you might have to pick like 3, 7, something like that. Any point that you see doesn't work, or 5 and 0 for x and y. That's all you would have to do. Does that make sense? Because then it's still testing the point that's not on the line. It's either going to be true or false. Great question. Right? And then the other one, if you had a fraction, when you cover and solve for fractions, remember. And I know there's a couple of versions of this. When I cover and solve for something like this, well, y-intercept would be at -1. X-intercept means I have to multiply by the reciprocal. When I multiply by the reciprocal of -1/3, I have to multiply by -3. Okay, and that's where I get that. Hope this will be solid. And then here it's the opposite of A over B. Knowing how to divide when you have fractions. When you're dividing by fractions, this is the same thing as saying 1/3 divided by -2/1.
Keep change flip.
There you go. Flip it. 1/3 times -1/2 equals -1/6. Also, if you notice your two ordered pairs, you have an x and a y intercept. Can you just walk the slope? Down 1, right 6, -1/6. Even if you didn't know how to do the opposite A over B, if you've got your x and y intercepts, those are 2 points. You can determine the slope between 2 points, can't you?
Oh my boy.
Every once in a while, maths. That's okay. Yeah, just make sure if worst case scenario for something like this, if you've got the two ordered pairs that are clean, just walk it. It's the easiest way to do it. Okay. All right. What else we got? How do you get the -6 for here? When I cover this and solve, how do you undo multiplying by a -1/3? You would multiply by its reciprocal, or divide by the -1/3, which is multiplying by negative. So you just multiply by the reciprocal to get rid of the coefficient whenever you have a fraction. That's the easiest way to do it. Don't look so sad. I'm sorry, you're going to like play loud obnoxious music. I can do that. I'm good at it. But